Uh, okay, so I think that today is more exciting. Right. So why building this tool? So one of um the pillars, we like call it pillars or constitutions or laws guiding this tool is that one, no errors will run silently, right? That there should be a reason behind any error. Why did this error happen? Maybe there was an error in the DB, right? Maybe um there was an error anyway actually in this project, in this tool, right? Maybe there was a short that needed to happen. Um is it trot I don't know how to pronounce that word actually. So that needed to happen, or it gives that vibes of explaining what is happening behind the scene, and not giving you that log vibes, right? It gives you just that friendship vibes that okay, you know what is happening, you know where this issue is happening from, that kind of a thing. So that was one of the things I had in mind why building this. So another one, which is the obvious one, is um that no two workers will claim a job at the same time, right? So that means that if there is a job at hand, or there is a job in a queue, right? Um, no two workers will be competing or will try to work on the same job at a time, right? So the example I gave previously was the example of a company hiring developers to build projects for clients that these companies are getting, right? So that's the idea behind this. Like that's kind of the what you can use to think about this too, right? So that means two developers cannot maybe want to collaborate to work on one product or one project. So it's just one developer per one project, one worker per one job, per job, right? And that was the one of the things I have in mind while building this thing. And so we have explained the security, the gateway part. We explained the config, we explained the DB, and we explained the explainability part. So we explained how we set up our auditor and explainability, right? On DB, right? How we explain, how we actually structured that table, and the expectation, right? And for any admin that want to query the table to know what is happening, they can filter however they want to filter, right? And we explain how jobs are queued, right? Which was still inside this repo. So, but now we just want to explain how jobs are being leased, right? Um, so that's what maybe this short is the it's not exaltation. This is not exaltation. Um, so just a brief explanation of how jobs are being leased. So before then, I want to go to my um. Let's go to our worker section. So this is this is where our worker is. Um, so I just want to show us how the how a worker, right, decides to pick a job, right? Like what now when you see that a worker has the ability to pick a job, how was it how was it configured? What's the logic behind it? Because they are not human being now. Because there's a logic that should tell a worker when to pick a job from a queue. So the structure of this is that a worker has the ability to pick a job from a queue, right? But now, what is the logic behind it? Mm, so this is where everything comes to play, right? And we define this worker ID on our config file, and this is just actually I'm not explaining this now. right? I just wanted to tell us that okay, there's a logic behind um this our worker and the worker getting a job, right? And maybe amount of attempts that should happen per queue, right? So job attempts, um, short leg, and like this is just what the this worker logic is doing. So this is just what I wanted to show. So um, so this is not my focus, sha. So I just wanted to just tell us that, okay, such a thing exists, right? So that you have it in mind while I maybe give us a rundown of what I want to do. So, but now here, this is just a very basic rundown of how um job is being leased, right? Now, first of all, this self here which we used, this self here we use in our so we use this self in our queue here. Right, so this is where we created this method, and this method took ownership of this structure. So we are now using, we are just borrowing this everywhere. So we don't want to take ownership of it again. Right? Just borrow it and do whatever you want to do inside there, instead of this method, right? So that's what we are doing here. Um, so this queue is actually trying to get a queue because now the jobs are being queued in our DB. So the DB is aware of the queue job, right? And now what this is trying to do is just to get a queue name, maybe a webhook or an email, right? And then we still want to get the worker's ID. So exactly which worker is working under this, that is actually handling this job. And also we want to give this job a limited time, right? How long will this job run before we say that okay, the worker have crashed, or there is no, like, that kind of a thing. So there should be a number of time that is given to this job to make sure that okay, by this time we actually expect you to finish this tax, right? So if you don't finish it after that time, if the time expires, we know that okay, you've crashed, something went wrong. So we can be able to pull that job and put it back to queue, right? And update our database to change it back to queue instead of running, right? And so this is our signature here that is returning um, let's just say it's turning two things. It's either it's returning an error and or it's returning an option. So when is an error is when maybe not everything didn't went well in our DB or SQL issue or whatever, right? But it's returning an option when option has a sum and a non aspect of it. So when you say sum in option, that means that you're expecting a job. You're expecting that at the end of the day, this job a job was given out, right? A job is now given out to a particular worker, right? When none happen is when this worker tried to pick up a job, but this job is not available. Maybe because the job is not available or because of delay, the short lead or whatever. I think I need to browse, let me browse this thing and maybe get the correct pronunciation. Um, um, let me check my listen. Let me first. Throttle. 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 Oh, okay. Okay. So, as we all know, it's throttle. Um. So now this is creating. This is just where the our whole stuff started, right? So this is trying to create a transaction for us, right? And this transaction is where our locked job is stored, right? So it gives us that this is kind of a source of truth that gives us that vibes or that assurance that provided that a worker have logged this job cannot be claimed by another worker, right? And before it's been committed on the Postgres, right? So this makes sure that okay, this job is handled is this job that is logged by this worker cannot be taken by another worker, right? And that's what this pull connection does for us. And so if everything went well, we continue. If it doesn't go well, there is an error shard that we expect to run. And so the flow of this job is like a story, right? And um the story is so nice. And so I'll just try to explain this now just as storytelling. So okay, so this is what is happening here. So this policy is kind of so what you're saying here generally is that you're trying to look up at the we're trying to look up the policy, right? The policy table of the queue we that this worker picked, right? So the worker picked a queue and say maybe this is the job you want to go for, right? So, but now the worker, we need to know exactly the max attempt, like how many attempts is expected from this worker, like from this queue. What is max attempt from this queue, right? What is the max flight and the throttle, right? So this is the things that now this query as what is doing basically is just trying to when it runs the SQL, right? It tries to map our returned rows to these tuples, right? So these tuples are expected to um return this guy here and this guy here. So respectively, it maps it out. So for any reason, and so this is what is expected to return optional. So this query is optional because maybe for some reasons the queue doesn't have any policy attached to it. But we actually gave it a default policy. If the queue doesn't have a policy, we give it a default policy. We added the structured tuple here that we actually gave a default policy here, and um, this is just we are trying to give it a very good range number that looks like it's unlimited, right? Um, but at the same time, um, we are not trying to put it as infinity, right? But the number we give to each of these, both the max attempt and the running attempts, that's how many jobs are currently running under this, right? Is kind of should be known, right? But we gave it a very big range, but not that the range is unlimited at the end of the day. Right? So this is so um, okay. So what this is doing actually is that this returns only um one one value for us, and the value what is just saying is just that from this queue from this queue how many jobs are currently running. So we are looking up at this table. Um, how many jobs are currently running on this table? So the idea is to give us load control. We want to have control of the loads. We don't want to overload our application, right? So how many jobs are currently running? And this information will come in handy um, because if there is a lot of jobs running and these jobs running have reached our max in flight, right? We will have to now push the trust will have to now push this job that this work have claimed to later and just commit what happened, right? So that's the essence of actually this 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 lookup, this query, and that's why we are running this. So what it's trying to fetch is only one, just one distance for us, right? Just a number, how many of this is running, and we're expecting an integer at the end of the day, right? So I just let me try to explain what is happening here because this is kind of something that is rampant across this job. Now, what is happening here is that when an SQL runs, right? The SQL, we are just saying that we are just telling this SQL to run inside of this transaction we created. So this transaction is an object, right? So when an SQL runs, it's it needs to borrow our transaction. It needs to borrow our transaction. It wants to borrow this transaction and not want to own it. And in the process of borrowing it, it needs this transaction to be mutable. It wants that borrowed access of changing the information because at the end of the day, this um, SQL will update itself as it runs, right? There will be a lot of changes happening as it runs. So what is happening here? Just we are giving it access to do the changes, have fun, right? Now this hash here is just kind of your the referencing this right, you're dereferencing it and giving it access to do whatever they want to do in it. So the references so you have access to um do your magic kind of, right. That's what is happening here. And so why this what this is doing generally is that it's asking the question of, so instead of this queue, how many attempts have happened over or in the last 60 minutes. So this is what this query is just asking. We want to query, we want to find and we want to get this information. Right. In the last 60 seconds, sorry, how many attempts, job attempts have happened under this queue? So how many attempts have happened? Right. That's really what we want to get. And at the same time we just still want to get an integer at the end of the day. Right. And then so this is where the throttle comes into play, right? So if the number of if the what is it called? If the number of jobs, right, that is running, so if the number of jobs that is running is too much, right? Um, maybe for any reason, okay, okay. This is not it. Let me go over to this. Let's find it. So if the number this is where the short I'll come back to this and explain this, right? So, so this is saying if the number of job here is too much, right? Let's say for any reason the number of jobs here is um, let's say um is above the max flight, right? So remember we set a default max flight here. So but if the number is above this max flight, we we really want to shift or adjust or forward this um job for later in that specific time. So maybe say the math flight is whatever it is, right? And so this is actually creating a unique ID for this, right? For now we are this is a return value. So why this? We are trying to explain why this job wasn't picked or why the job didn't run because you have restricted the influence. So there are a lot of jobs running under this queue. So because of that, we are shifting it for later, right? And that's what this explanation will be. So that means even if an admin can still query this information, right? And yeah, that's it. And so um uh, so this is also saying So the max attempt, just the attempt, you are trying to attempt something that is above what the max attempts, right? So this queue have had a lot of attempts, mm, that is beyond the max or above the max attempt per minute, right? Based on what our policy gave to us, right? What we query from the policy, right? We are expecting to shift this expecting to shift this man here, that job here, to later, right? We are giving it a specific timeline. So maybe because of the exceeding. Now what is happening here is that we are giving our reason why this thing happened, right? We are giving our reason why this thing happened, so that our um ingestion recorder will have a record of this, so that even if somebody wants to query, they will know what is happening, right? Then this is where the whole thing is now happening. This is where we are trying to maybe forward this thing for later, giving it a milliseconds, right? This will just be how many milliseconds interval from that time, right? That's what you are giving this thing. So you will run later, not now, because the the limit have been exceeded, right? And we execute the update, right? So that's basically what is happening here. So going back to this guy here. mm, yeah. Now this is where um our logic for making sure that it's only one worker that have access to a job at a time was implemented, right? Um, so this is just trying to query a row, right? And then here we are trying to assign um, a job to a worker, right? And so the job we are assigning to a worker must be queued, right? And the job is something that should is either that is something that was scheduled to run before that the time have actually reached to run, right? Or this is now the priority order of actually um locking a job, right? So if a worker choose a job, right, from a queue, and it meets this kind of requirements, right? It meets this requirement, you update that this job have already been taken by a particular worker, right? And now the idea behind it is that for any reason this job already have been taken, right, by a worker, what you have to do is just to skip the locked job, right? So this is just saying if there is a job available for me and it's queued, I just lock it, and I am the owner of the job, right? And so if the job is locked, when another worker, maybe when worker B wants to pick this job and see it as locked, just keep it and go ahead immediately to look for any other job for me. Right? That's what is happening here. That's the This is the basic explanation of what is happening here. Now, before this, you come to this point, right? Before you come to this point, the process of knowing the policy of the in-flight and attempt and the throat part of it must have actually taken place, right? Then before this, right? No, 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 no. So now this is the correct flow. This is correct flow of this. So when these two parts are done, right? So you have selected the interval. You have queried the attempts per minute, and you've queried this, right? Then you lock this user to the worker, right? You lock a job to a particular worker. then we will now go through this flow. So if this job that is locked, if the flight in flight is greater than the max flight, we are shifting this job to later. And now shifting this job to later. So now shifting this job to later, will you will have to commit to public that this transaction have been closed, and the reason will be actually be public on Postgres. First of all, the reason will be public on Postgres, and the worker that was locked for this job will be relieved of his job, because I mean the max in flight have been exceeded. This job have already been shifted to maybe maybe 5 or 25 and 250 milliseconds, or the attempts have been exceeded, right? So because of that, you don't want to overload this work. You don't want to overload this um this product, right? You don't want to overload it. So you want it to work as at a very good pace, but at least at the same time give us a very good result, right? So what is happening here is that we commit this to the public. And remember, everything that is happening inside our transaction. It's not yet public to the DB yet, right? Now, if everything goes well, if the trust is being if this thing is being committed, your the return value is small, because there is no job for this worker again, right? The same also happens here, right? So if for any reason um this reason was met, the attempt is much per minute is more than what is expected. This is being committed, pushed publicly, and then this none is being returned, right? So we follow the process of policy is being getting policy of the in-flight, how many jobs are running, how many attempts have taken place, and we try to log the job, right? Then the short will not do its own calculation to know if this thing is actually something we can go ahead to do, right? Because of load control. So if everything goes well, then we will now do an update. So this query is trying to update our log job from queue to running, right? Changes it from queue to running, then logs the actual worker that is working on this job, and then at what time was this logged, and now set an expiring date, expiring time, how long it will take for this job to how long it will take for us to now say that this job, the worker that is working on this job have crashed into it, or whatever reason, right? And an update will still be returned of, okay, this is what is happening, and then we're expecting to return the value of this to us, right? Then we still commit this thing publicly that, okay, this job is now owned by this worker, and this is how long it will take for this worker to do whatever they want to do on this job, and this is what will be returned. So we are returning a value that the job have been released to somebody, to a particular worker, right? And so if for any reason this thing expired, the worker have exceeded their limit, or the time have expired, um, we are expected to do some logical action, right? So what is being expected to return here is an integer. So now, if for any reason this job have been expired, now this query is trying to actually relieve this worker of this job. Maybe it crashed for any reason. The worker have exceeded the limit of the job. So it's just like a developer that the deadline have reached and you're still giving complaint, I will do it tomorrow, I'll do it tomorrow. That kind of thing can't happen here. So when the work that was assigned you picked is exceeded, what you'll be doing is just that there will be somebody in charge of you trying to relieve you of that job, right? And then turn all this log to null. So nobody is holding it and nothing is happening. So is what this man is checking is querying on the DBs if there's any job here that is still running, if the status is running, we have to change everything to queued, right? And if this thing have expired, right, or still this, we change it to queue. So we are putting it back to the queue job so that another worker can want to pick it up. So that's what is happening, and we are trying to execute this to our self.queue, the connection we created, and this is giving us access to a job that is successful. And this is actually making sure that if you're not the one that actually picked this job, you don't have any right to pick it to actually mark it as success. For example, let's say worker A picked the job and worker B now came to say that this job have successfully been accomplished. It can't really happen. So we are making sure that the ID, the person that logged this job, that this job was the ID that this job was locked under, the worker that this job was locked under, the same ID that is marking this as successful. And so we are not really expecting any data. We're just expecting that this is successful. So that's really what these few functions are doing, right? So this is what they are doing for us. And yeah, that's just basically it.